This is Joseph Cobb. I'm going to be walking through my individual project, which is a battery tester. The tester will measure voltage of a battery and correspondingly light up LEDs to represent the measured voltage. I used a red LED to show that the battery would need to be replaced soon, which was around when the battery was zero point 0.8 volts and under. A yellow LED meaning it needed to be replaced soon, which was 1.1 volts to 1 volt, and then a green LED showing that the battery is good, which was when it was 1.2 volts and above, and that was for the 1.5 volt batteries. On the left side of the schematic is circuitry that will measure the voltage of any 1.5 volt battery. It will then light up a red LED if the voltage is over 600 millivolts, then a yellow LED if the voltage is over 900 millivolts, and lastly a green LED if the voltage is over 1.2 volts. I set these values through a voltage divider, which entered into the negative pin of a LM293 comparator. The comparator will output high if the voltage is under the set voltage reference. However, that contradicts how I said the circuit would work. Therefore, I placed a BS170 MOSFET to invert the output and generate a lit LED. Some key things to note about the comparator that you'll see in the schematic is that the comparator will not work unless the LED is connected to VCC. Secondly, when the positive pin of the LM293 is greater than the reference voltage, then VCC will be output. Inversely so for the negative pin and ground of the LM293. On the right side of the schematic, the circuitry behaves the same as the left side, but is designed for a 9-volt battery. Therefore, the main differences are in the resistors that set different reference voltages for the LM293s. The red LED voltage range is from 1.8 volts to 3.6 volts. The yellow range was from 4.5 volts to 5.4 volts, and the green was 6.3 volts and above. So I'm now demonstrating the 1.5 volt side of the battery tester. I am measuring the reference voltage of the green LED, and it is coming out to 1.5 volts. Now I'm measuring the reference voltage for the yellow LED, and it is around 1 volt. And lastly, I'm measuring the reference voltage for the red LED, and it is coming out to 0.75 volts. So I am now going to show the range of the battery tester by attaching the tester to a DC power supply. You will see as the voltage supply drops below the reference voltage, the LED will be lit. I was unable to get the output of the LM293 to invert, so I modified the circuit's reference voltages to be at the top of each comparator range, meaning the green, yellow, and red LED voltage range. So my final circuit turns on the LED when it drops into the range from green to red, and the lowest voltage range is of all the LEDs is the range that the battery is in. As you can see, the green LED came on as the voltage dropped below 1.5 volts. The yellow is now going to come on as it drops below 1.1 volts. And lastly, the red LED turning on as we drop below 0.8 volts. Moving on to the right side of the schematic, I am demonstrating the 9 volt tester. I am measuring the reference voltage of the green LED, which came out to 7.1 volts. Moving on to the yellow LED, I'm going to measure the reference voltage, and it comes out to 5.4 volts. And then lastly, the red LED will be measuring the reference voltage, and it comes out to 3.5 volts. I will now move on to use a DC power supply to simulate the range of the 9 volt battery tester. And here you'll be able to see the LEDs light up with the change of voltage, just like on the 1.5 volt battery tester. So as we drop below 7.1 volts, the green LED will come on right there. And once we go past 5.4 volts, the yellow will come on. And lastly, as we drop below 3.5 volts, the red LED should come on. A few things that were different from my abstract were that I wanted to use one red, yellow, and green LED for both the 9-volt and 1.5-volt battery tester. However, I tried to make an OR gate with 2N7000 MOSFETs, but failed to get the desired outputs from the OR gates. Secondly, in my demonstration part of the video, I wanted to use batteries to show the range of the tester. However, I did not find batteries that were drained as far as 0.8 volts. I learned that some batteries like AA's have cutoff voltages around 1.2 to 1 volt and therefore never drain any farther. Here's an example of me demonstrating this with the green LED turns on if the battery is above 1.2 volts and red if it is below 1.2. I also found that it depends on what the battery was used for. If it was used to power an LED, then they would be so-called dead sooner because LEDs have their own turn-on voltages. If you do not meet the LED's turn-on voltage, the battery will simply not be demanded of. However, if you powered an incandescent light bulb, it would be different. That's because incandescent light bulbs do not have turn-on voltages and instead would slowly get dimmer as the battery voltage depleted. That is it for my individual project, the battery tester. Thank you.